So they give us the weight of the aluminum ingot, and the weight of the aluminum is going to be 89 newtons. We should find the density of aluminum in any physics textbook, and this is going to be 2,700 kilograms per cubic meter. And they want us to find the volume of this ingot. So we are going to say that weight equals the mass times the gravity, given that weight is a force. And to find the mass, we simply need to isolate and divide by gravity. And plugging in for our constants, 89 newtons divided by 9.8 meters per second squared, we have a mass of this aluminum ingot, which is going to be 9.082 kilograms. At this point, we can say, okay, what is the volume? And we can define the density as the mass over the volume, which means that the volume is simply going to be the mass divided by the density. Plugging in for our constants once again, we have 9.082 kilograms for the mass, divided by the density of aluminum being 2,700 kilograms per meters cubed. And this gives us a volume of 0.00336 meters cubed. Once we have this, we can then see the apparent weight. So the apparent weight, this is completely submerged in water. So the tension in the rope, F sub T, is simply going to equal the weight of the ingot minus the buoyant force, given that this entire aluminum ingot is submerged in water. We have a formula for the buoyant force. So this is going to be weight, again, minus the density times volume times gravity. So this would be the density of the water. V will be the volume that is displaced by the volume of water that is displaced, which is also equal to the volume of the iron ingot, given that the entire the aluminum ingot, rather, is completely submerged in water. Plugging in for our constants, we have 89 newtons. And then minus density of water is going to be 1,000 kilograms per meter cubed times the volume that is displaced, 0.00336 meters cubed, times gravity, acceleration due to gravity, 9.8 meters per second squared. Solving for this, we find that the force tension, or the apparent weight of the aluminum ingot, is going to be 39.072 newtons. So this apparent weight is simply going to be the weight of the aluminum ingot. However, there's this buoyant force that is pushing the aluminum block upward. And so the weight minus this buoyant force will give us the apparent weight, given that this aluminum ingot is completely submerged in water. And again, that answer is 39.072 newtons. And that's the end of the solution. Thank you for watching.